The transit CSR configuration commands open here, and I've scrolled down to line 38. I'm not going to go through this line by line because, again, this isn't a Cisco specific course. Instead, I want to point out some general tips to help you when you're setting up your own transit VPC. Notice I'm creating a new tunnel interface called Tunnel 10. Earlier, when AWS generated the transit CSR configuration, it created two tunnel interfaces named Tunnel 1 and Tunnel 2. I'm using Tunnel 10 for the VPN connection over to Charleston because I know that tunnel interface will not conflict with the existing VPN tunnel interfaces on the transit CSR. The moral of the story is make sure you don't accidentally overwrite the configuration that AWS gives you. Okay, let's scroll down to line 60. Under the BGP router configuration, I've placed a redistribute connected command. This simply advertises the private subnet addresses configured on the transit CSR, which of course includes the transit subnet 10300/24. Okay, now I'm going to copy and paste all of these commands into the transit CSR. Go ahead and select all here, and then copy. Now let's jump over to our SSH session with the transit CSR. I'm going to go back into configure terminal mode, and then I'm just going to go ahead and paste this. Next, I'm going to open a SSH session with the Charleston router. And as you recall from the diagram, the name of this router is CHS-R1. Let's go ahead and see if we can ping DB1, ping 10.22.41, source 192.168.167.1. And just as we saw in the diagram, that .1 address is the Charleston router's IP address. So it looks like this works. Excellent. Now we want to see the routes that the Charleston router is actually learning from the transit CSR. How do we do that? Well, from here we can do a show IP route BGP. And notice we have two routes here. 10.2.00/16, which is the shared VPC CIDR, and 10.3.00/24, which is the transit subnet. Now let's jump back over to the transit CSR. And from here, I'm going to exit configuration mode, and we're going to do a show IP route BGP. And notice we have two routes, 10.2.00/16, which is the shared VPC, and 192.168.167.0, which is Charleston's subnet. Now let's take a look at the shared route table. Scroll down to the shared route table. Go ahead and hit refresh. And then let's scroll down this list of routes here, and wow, look at this list. We've got several new routes here, and notice we have one for the Charleston subnet. The virtual private gateway is learning these from the transit CSR. So what this means is that our routes are being advertised end to end in both directions, and we can pass traffic end to end in both directions. And that means our transit VPC is working. Let me ask you something. What if you didn't want this? I mean, not that you don't want the transit VPC to work, but what if you wanted to block the Charleston subnet from accessing the DB1 instance? How would you do that? Well, let's jump back over to our security groups. Let's go ahead and locate the database security group. Ooh, here it is right here. And then look at the inbound rules. Now what you could do is you could simply remove this 192.168.0.0 subnet here. And that would prevent Charleston from having at least SSH access to the instance. Now you might think, okay, that would be fine, but what if I want to block it before it gets all the way over to the database subnet? What if I want to block it at the transit subnet? Now, click on the transit CSR security group. Notice that there's no rule allowing traffic from Charleston, and yet traffic is still making it through. Why? Well, it's because the traffic from Charleston is coming over a VPN tunnel, and AWS doesn't actually see the IP packets from Charleston when they hit the transit VPC. What this means is that you cannot use a security group to block encrypted VPN traffic from coming into a transit router. You'd either have to block it from within the transit router, or you'd have to actually block it at the instance level itself using security groups. And as always, you could use network access control lists to block it at the subnet level.